Earth's core has stopped and may be reversing direction, according to a new study. The surprising finding might solve long-standing mysteries about climate and geological phenomena. This is by Becky Ferreira. Earth's inner core has recently stopped spinning and may now be reversing the direction of its rotation, according to a surprising new study that probed the deepest reaches of our planet with seismic waves from earthquakes. The mind-boggling results suggest that Earth's center pauses and reverses direction on a periodic scale lasting about 60 to 70 years, a discovery that might solve long-standing mysteries about climate and geological phenomena that occur on a similar time frame and that affect life on our planet. Of course, it must be noted that this is more or less the plot of the 2003 disaster film The Core, but there is no need to worry about averting an impending apocalypse by nuking the center of the Earth. While the core's rotation influences Earth's surface environment, scientists think this periodic spin switch is a normal part of its behavior that does not pose risks for life on our planet. Earth's inner core is a solid metal ball that is 75% the size of the Moon. It can spin at different speeds and directions compared to our planet, and it is nestled within the liquid outer core, but scientists are not sure exactly how fast it spins or whether its speed varies over time. Located some 3,000 miles beneath our feet, the core experiences intense heat on par with the surface of the Sun. Because it is so remote and of course difficult to study, the inner core remains one of the least understood environments on our planet, though it's clear that it plays a role in many processes that make our world habitable to life, such as the generation of Earth's protective magnetic field, which blocks harmful radiation from reaching the surface. Now, Yi Yang and Xiaodong Song, a pair of researchers at Peking's University Sinoprobe Lab at School of Earth and Space Sciences in China, have captured surprising observations that indicate the inner core has already ceased its rotation in the recent decade and may be experiencing a turning back in a multi-decadal oscillation, with another turning point in the early 1970s. According to the study published on Monday in Nature Geoscience, they said there are two major forces acting on the inner core. Yang and Song said in an email to Motherboard, saying one is the electromagnetic force. The Earth's electromagnetic field is generated by fluid motion in the outer core. The magnetic field acting on the metallic inner core is expected to drive the inner core to rotate by electromagnetic coupling. The other is gravity force. The mantle and inner core are both highly heterogeneous, so the gravity between their structures tends to drag the inner core to the position of gravitational equilibrium, so-called gravitational coupling. If the two forces are not balanced out, the inner core will accelerate or decelerate, they said. Both the magnetic field and the Earth's rotation have a strong periodicity of 60 to 70 years. We believe that the proposed 70-year oscillation of the inner core is driven by the electromagnetic and gravitational forces. Song has spent decades trying to unravel the mysteries of the inner core by studying seismic waves that pass through this distant region. He was part of the team that first reported evidence of the inner core's rotation in 1996 by measuring slight time or temporal changes in these waves, which are generated by earthquakes. However, the origin of the temporal changes has been a matter of debate within the geoscience community ever since, as some scientists think that the wave patterns arise from phenomena at the boundary between the outer and inner core. Some researchers are still arguing that the temporal changes do not come from the inner core rotation, but from localized deformation at the inner core boundary, Yang and Song said. With their new study, the pair tried to gather more data over a longer duration to test different models. To that end, the team studied seismic waves that pass through the inner core made by earthquakes that occurred since the 1960s. In particular, they looked for doublet events, which are repeated earthquakes with nearby identical waveforms that occur at common receivers. According to the study, by analyzing the slight temporal changes between these doublets, Yang and Zhang were able to prove the rotation of the inner core. And as it turned out, the temporal changes reached a minimum around 2009, suggesting that the inner core had paused rotating around this time, creating seismic observations that seem more static. The team was even more astonished when they identified a similar turning point in the early 1970s, hinting that the core stops and reverses rotation on a periodic cycle. Yang and Song said to Motherboard, "Our results further support the inner core rotation and, more interestingly, reveal the multi-decadal pattern of the rotation. The results offer an unprecedented look at the searing pit of our planet, a region that continues to evade clear explanation, and it also has big implications for understanding the familiar world we inhabit on Earth's surface." For instance, the team notes that the same multi-decade cycle has also been observed in Earth's climate system, as global mean temperatures and sea level rises appear to oscillate every 60 to 7 years. The length of Earth's day, which shifts slightly over time, also seems synced to the proposed cycle. For this reason, the new findings may imply dynamic interactions between the deepest and shallowest layers of the solid Earth system, according to the new study. We pointed the existence of similar periodicity of different observations forming a resonating system, Yang and Song told Motherboard. They said the linkage, however, is less clear at the moment. The gravitational coupling between the inner core and the mantle may cause deformation of the Earth's surface. You know what that means. That means, of course, earthquakes and volcanic activity. So this may, the decoupling between the inner and outer core, between the inner core and the mantle may cause deformation of the Earth's surface, which would affect the sea level, they said. The changes of the sea level and the Earth's rotation may affect the global atmosphere, circulation, and temperature. The resonance of different systems may also amplify the mutual interactions. It's tantalizing to imagine that our most mundane experiences, such as the length of our days, the climate patterns that guide our local weather, might be sculpted by the rotational cycles of a weird metal ball at the center of our world. Untangling these nuances will require new models and continued observation of Earth's enigmatic central realm. The next steps are to build quantitative models of the physical mechanisms of the multi-decadal oscillation system and to monitor how the rotation changes in the future, Yang and Song said. We'd expect it to rotate westward relative to the surface of the Earth in the coming years and decades, the pair concluded. Seismic waves are still the best way, and thus continuous operation of high-quality seismic networks is crucial in this regard, they said. This is from Vice, and it's on Out of Minds 2 by Becky Ferreira. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box